Good morning, Algebra 2 students. We're going to continue on in our chapter with trigonometry. Today we're going to be looking at evaluating trig functions of any angle. Now, so far we've looked at right triangle trigonometry for the most part, and we've used this mnemonic device, SOHCAHTOA, to help us think about how to find sine, cosine, and tangent. Now, SOHCAHTOA is a great way to remember sine, cosine, and tangent if we're working with a right triangle, because within a right triangle, the angles that are, other than the right angle, they are both acute angles. And so we can always think of them as, here's the opposite side of the hypotenuse, or the adjacent side of the hypotenuse, etc. But what about if we're asked to find something like this? What is the sine of negative 270 degrees? Well, all of a sudden we're in a little bit of trouble because negative 270 degrees is not an angle that you're going to find in a triangle. So how do I do the opposite of the hypotenuse if it's some goofy, humongous negative angle like this one? Well, that's what we're going to be figuring out in today's couple of video lessons. So, here we go. General definition of our 6 trig functions goes like this. I'm going to start by putting a circle on a coordinate plane. So I have an x-y axis set up over here, and I have a circle drawn whose center is at the origin. Now, the equation for such a circle would be right here. X squared plus y squared is equal to r squared, r being the radius of that circle. So, given that information, what I'm going to do is I'm going to label a point out on the edge of the circle. I'll put one right here. Now that point, any point in the circle, could be labeled as x, comma, y. And then what I'm going to do is I'm going to extend a radius from the origin out to that particular point. Now remember, in my equation, x squared plus y squared equals r squared. R is the length of the radius. So I'm going to go ahead and label this as being a length of r. Now, if I wanted to find the sine of the angle that I've created that's in standard position, so beginning at the positive x-axis and rotating all the way around where this has now become the terminal side of my angle, I'm going to use the following definitions to do so. Again, this is an obtuse angle, opposite over hypotenuse. All that stuff doesn't necessarily apply because it's not part of a right triangle. However, when I define my 6 trig functions, I'll start by defining the value of sine. So the sine of theta, that angle we just created, is going to be equal to the y value of the point through which the terminal side passes, divided by r, the distance from the origin to that point. Cosine is going to be equal to the x value of the point through which it passes, divided also by r, the radius of the circle, or the distance from the origin to that point. And finally, the tangent of theta is going to be equal to y over x, the y value of that point through which it passes, and divided by the x value of the point through which our terminal side passes. Now, while it may be confusing because we like to think of things in terms of SOHCAHTOA, I want to show you something that might help us figure this out. So, if I were to, I can't draw a right triangle here because that's an obtuse angle, but what if I were to maybe drop a line straight down from that point to the x-axis, and then continue over to the origin? All of a sudden what I've drawn is I've drawn a right triangle. Now if I were to label the sides of this right triangle, well, the hypotenuse is obviously r because that's the radius of my circle. Now if I were to label this side right here along the x-axis, well, that's going to be whatever the x value of that point might be. I went x units this direction, and then I went y units upwards in that direction. Now, if I wanted to find the sine of theta, now this angle over here is obviously an obtuse angle, but what I've created is I've got this teeny little angle right there. That would be called a reference angle, something we'll learn about in a future video. But for the time being, if I were to look for, we'll call that theta prime, theta with a little y. If I were to find the sine of theta thinking in terms of SOHCAHTOA, the opposite angle, or the opposite side, excuse me, would be y, and the hypotenuse would be r. So SOHCAHTOA is opposite over hypotenuse. Sine is opposite over hypotenuse, so sine of theta prime would be y over r. Interesting. Cosine, the ca part of SOHCAHTOA, we've got the adjacent side over the hypotenuse. That'd be x over r. Same thing we got over here. And then finally the tangent would be opposite over adjacent. Well, that's going to be y over x. The same thing that we wrote down right here. So again, it's kind of a goofy way to go about thinking of it, but that's how we define our 6 trig functions. Y over r, x over r, y over x. Now, for the other 3, if you remember, cosecant, secant, and cotangent are all reciprocals of our 3 main functions. So I'm going to go ahead and write cosecant as r over y, secant will be r over x, and cotangent will be x over y. Now, the one little extra disclaimer I have to add to a couple of these is that because I'm doing some division here, I can't divide by 0. It's still a math thing that doesn't work. So, as I think about these 6 functions, y divided by r, well, r is a distance. It's a distance to that point, and r is never going to be a negative value because it's never going to be 0 either because it's a distance. Okay? So, I'm dividing by a number that's going to be in existence. I'm dividing by a number that's going to be in existence. Now here, x, what if x happened to be 0 for some reason? Well, if that were the case, I can't divide by 0 and suddenly my tangent function would be undefined. So I have to add on to this a little comma and the fact that x cannot equal 0. And I have to do the same with cosecant for y. Y can't be 0 for this function to work. Secant, x can't be 0. And cotangent y can't be 0 again. If it is, that function becomes undefined and thus no good. Now, let's put this into practice with an example. So, we're going to let -3, -6 be a point on the terminal side of an angle theta in standard position. Evaluate the 6 trig functions of theta. So as we do this, drawing diagrams is a huge help in a lot of trig problems. So what I'm going to do is I'm going to draw what's going on here. Now I've got my circle equation. I have this generic circle that's centered at the origin, and I'll use it and sort of make it work. I know that -3, 6 is a point on the terminal side. So I'm going to draw -3, 1, 2, 3, and -6, 1, 2, 3, 5, 6. And we're going to estimate, we'll put this point right here. And we're going to say that point is roughly at -3, -6. Now, in the instructions it told us that that point is on the terminal side of angle theta. So I'm going to draw my angle now. Standard position means the initial side is on the x-axis, and the terminal side goes through that point. So this is the angle that I'm working with. That's angle theta. Now, as I find my 6 trig functions for angle theta, as I defined sine, cosine, tangent, I was using 3 variables. I was using x and y and r. So what I'm going to do is I'm going to try and label those 3 things. I'm just going to write them down. Usually I think this helps. X I know is the x value of the point, well, it's -3. Y is the y value of the point through which it passes, so that's -6. R is, think of it as the radius of that circle, the distance from here to there. Well, how do I find that? Well, Pythagorean Theorem, which in essence is the same thing as this circle equation. So points on the circle are equal, squared and added together equal the radius squared. So I'm going to go ahead and plug in the things that I know. I've got -3 for x, I'll square that. I've got -6 for y, I'll square that. Add them together, I'll be able to solve for r squared. So, a little quick math here. -3 squared is 9, -6 squared is 36. 9 plus 36 is 45, so 45 is equal to r squared. I want r itself, so I take the square root, and I can say that r is equal to the square root of 45, which I'm going to simplify into 3 times the square root of 5. 3 because the square root of 9 is a factor of the square root of 45. So that's the value of r. 3 times the square root of 5. We'll write that down here. Now that I know my 3 variable values, I'm going to go ahead and plug them into the different functions. So the sine of theta, sine is equal to y over r. So when I start, I take y over r. Now this is something that I need to simplify. I'll start by simplifying the fact that -6 over 3 will be a 2 over 1. So we now have -2 over the square root of 5. Well, I don't like radicals in the denominator. I'm going to need to multiply by the square root of 5 on the top and the bottom. And as I do that, times the square root of 5 over the square root of 5, we're going to end up with a final answer of -2 times the square root of 5 over 5. Move this out of the way. So there would be the value of sine of theta. Now, we'll do the same thing to find the cosine of theta. We take the x value this time over the r value. So negative 3 over 3 times the square root of 5. Once again, I can do a little simplifying first. That's going to turn into negative 1 over the square root of 5. Multiply top and bottom by the square root of 5, and we're going to end up with this, the negative square root of 5 over 5. So there's our value for cosine. Tangent is going to be an easy one because tangent is equal to the y value over the x value. So we're going to have negative 6 over negative 3, which is going to equal positive 2. So here I've got the first 3 of my trig values for that particular angle. Now, finally the other 3, remember those are just reciprocals. Cosecant is going to equal the r value over the y value. So 3 root 5 over negative 6 is going to simplify to the 3 and negative 6. We'll do some canceling. We're going to have negative square root of 5 over 2. For the next one, secant is going to be the reciprocal of cosine, so that means secant is going to be r over x. So I start with 3 root 5 over negative 3. That's going to simplify down to being just negative square root of 5. And my final one, cotangent, is going to be x over y, so that's going to start as negative 3 over negative 6, which will simplify to a nice positive 1/2. So, keys to evaluating 6 trig functions when given a point on the terminal side of an angle in standard position. Identify x, identify y, and then use the Pythagorean Theorem or the circle equation to identify r. Put the numbers in the right places and simplify.